Today we're going to take a look at solving radical equations. We're going to figure out how to deal with root signs when you're trying to solve for a variable. Let's do a little recap on what the opposite of roots are. We know the opposite of add is subtract and the opposite of multiply is divide. So what is the opposite of a root? The opposite of root is a power. So the way to make our square root x equal to make that root go away would be to do the opposite of that root. The opposite of square root is squaring. So that means we'll have to also square the other side. The root and the power cancel each other out, leaving us with an answer of 4. Here we see that we have a cube root. What's the opposite of a cube root? It'd be doing a cube, or a power of 3. So if we do that to one side, to make sure that you also do it to the other side. The power and the root cancel each other out, leaving us with an answer, 27. Now you always need to make sure that you check your answers. It is possible sometimes in problems like these that an answer you get is actually not right. So let's check and see if both these still work out. Take the 4 and plug it back into the original equation. And we see that 2 does equal 2. So it checks off. So x does equal 4. Let's check the second example. Plug the 27 back into the original problem. Will it come out equaling 3? Yes, it does. So these answers do work out. In this example, I see that there is no root sign yet. I have a fraction exponent that will turn into a root for us to deal with. Before we do that, we need to make sure that we get and isolate x. So let's get rid of the negative 10 by adding it to both sides. We get 250. Now you might want to, at this point, turn the fraction exponent into your root and your power, but do know that that is only attached to the x. It is not attached to the 2, otherwise there'd be parentheses around the 2 and the x. So at this point, before we can get to the exponent, we're going to need to get rid of the 2 by dividing by it. And this is what I get. So now let's write this as a radical and a power. So there's my square root for the bottom of the fraction and my power of 3 for the top of the fraction. So at this point I see that, well, the opposite of that square would be the opposite of the square root is to square it. Yeah, I could go ahead and do this, but who really wants to try to work out a problem after trying to square 125? So instead, let's back this up. There's another way to write this problem. Instead, how about we write this as the square root of x cubed. The reason why this is a little bit of a better choice is the opposite of that power is the root. So if we do the cube root to both sides, that actually gives me an easy answer on the right-hand side. The cube root of 125 is 5. And that also allows me to take out the root sign and the 3. So what do I have left over is the square root of x equals 5. The opposite of a square root is a square. Square both sides. And my final answer is x equals 25. Okay, then. In this problem, before I can get to any of the things underneath the radical sign, we're going to have to get rid of the plus 2. So let's minus 2 to both sides. And we get 3. Notice I did not do negative 7 plus 2 because the plus 2 is not underneath the radical sign. The opposite of this root is a power of the same thing, which is 2. So let's square both. Now the root can cancel out with the power, leaving me with this answer. Add 7 to both sides. Divide by 4. Let's not forget to check our answer. Take the 4 and plug it back into the original problem. Will this equal the 5 that we started out with? 4 times 4 is 16. 16 minus 7 is 9. Square root of 9 is 3. And 5 does equal 5. So this checks out. So our x equals 4 is really our answer. This is your last example. In this problem, I have x's on both sides. But I do need to make this a little bit simpler. I could try to add 4 to both sides. Then I'll have a plus 4 after the square root sign, and that still doesn't get one of the x's completely alone. I could try to do this. It gets x alone by itself on one side, but now x is not alone on the other side. So this is not going to work. Let's try the opposite of that. Instead of looking at the left-hand side, let's look at the right-hand side. The opposite of the square root is a square. So if we square this side, we square the other side. The most common mistake is to do this. This is not what we want to do. The second most common mistake is to just do this. This is also not right. If you're squaring one side, you have to square the other side. And the other side is a binomial. So you need to make sure you square it as a binomial if it's already a binomial. So we end up with x minus 4 times x minus 4. The root and the power cancel each other out, leaving us with 2x. Let's multiply and FOIL this out. X squared minus 8x plus 16 equals 2x. And now let's subtract 2 on both sides, leaving us with x squared minus 10x plus 16 equals 0. Why do I want to make this equal to 0? Because it's a trinomial, it's a quadratic. We can solve quadratics by factoring. I get x minus 8 and x minus 2. So our two possible x's is x equals 8 and x equals 2. I have two answers, so I need to check on both to find out if both of them work, or neither of them work, or maybe only one of them works. So let's check it. Let's start with the 8. So 8 minus 4 equals the square root of 2 times 8. So I plug the 8 into both of the x's. So 8 minus 4 is 4. 2 times 18 is 16. And 4 does equal 4. So plugging in 8 did work. So x does equal 8. But also now let's check the other one. Okay, let's plug a 2 in for the x. 2 minus 4 equals the square root of 2 times 2. So I plug in the 2 into both the x's. I end up with negative 2 equals the square root of 4. And negative 2 equals 2. This is a big no. Negative 2 does not equal 2, so our x equals 2 is not an answer. Our only answer for this problem is 8 and not 2. Okay, I hope this clears up your questions about solving radical equations. If you have any questions, please leave me a comment or send me an email. Otherwise, I'll see you back in class.